Hello everyone, this is Shumunto here again for you from Codon, the coding particle. So today we will be discussing a very interesting topic of creating CDS views via speech. So in order to do that, we don't have to write codes even in Eclipse editing. Okay, so we will be leveraging Python speech to text functionality, and we'll be integrating the speech to text functionality of Python with ABAP. Okay, so that you just open up your Eclipse environment and find this CDS views created. And what we'll be talking to this tool is nothing but tokens. What are the tokens? Tokens means there are different parts of a CDS, right? I mean, there are some header annotations. Then we have the source tables. Then we have the target tables. Then we have the associations, okay, association names. And we have the field list. We have the where conditions. So these are the different things that we need in order to create a CDS view. So we have segregated all these subparts or all these portions of a CDS views as tokens, okay, and we have given every token a unique name, and we'll be talking these token names to this particular tool, okay. And what this tool will do, this tool will gather these tokens what we are talking to, okay, and they will refer the underlying token tables, and it will construct the full CDS view code, and it will create the CDS view for us. We actually thought that in some untoward cases, if a particular coder, we are all coders, right? So if any unfortunate coder from our community loses eyesight or ability to type, okay, so at least this tool will be handy somehow, because he will be able to speak and code, okay. Of course the tokens he will have to create, okay. So this is the very first step towards making coders able to speak and code, okay. And I'm sure as Codon will be doing its bit to enhance this tokenization or the speech to text functionality as flexible as possible in future, so that it actually becomes a cakewalk, okay. And I'm also sure about this fact that there are brighter minds outside this room who will also be nurturing this idea and come up with a very better version of the tool as it is today. So from Codon we will be doing our bit, and we expect all of us to do our bit as well. So, and one more thing, we should be thankful to ChatGPT in order to do that, because you don't have to be a Python geek, okay, to leverage this speech to text functionality and integrating with an app, okay. You just need to know how to tie the knot between these two platforms, and it will work like a magic, okay. So we have been able to achieve some part of it, so we will be demonstrating that to you today, and hopefully, as you have been always doing generously supporting Codon, you will be coming up with better versions, better ideas in future for this tool, and we are eagerly looking forward to that, okay. So thank you so much for your support all along, and let's see how the code, how the tool looks like, and how we actually create a CDS views via speech. Thank you. Hello everyone. So we are now entering the second part of the video where we will be actually witnessing the tool, experiencing the tool, and we will be first generating the token file, okay, and then we will be reusing the token file to create the CDS. As already stated, tokens are parts of the CDS views, and this tool has a dedicated section to maintain your tokens, and you can freely edit, update, create your new tokens to add flexibility to your speech model. Okay, so let's see. This tool is called Hanable, to rhyme with enable, as you already know. So let's see, how does that token look like, the token area. This is your actually token area. Okay, so we have different parts of the token maintained here, different tokens. Tokens are having unique token keys. Okay, so each and every part actually has a sub part of the full CDS. Okay, you can, I have defined it like this. You can have it, I mean, much more easier as per your understanding level. Okay, so now suppose in this case we are maintaining ZDDL SPCH as the DDL view and ZCDS SPCH 6 as the CDS view. You can always change it to 7, 8, 9. Why I am making it 6? Because in my Eclipse you can see there is no 6 as such. Okay, so let's see if it can generate actually. Okay, so that's it, and we have added these fields, okay, from matnar, matcal, mtart. Okay, we have given this here, and you can always change this to suppose 6. Okay, so now after this token maintenance as per your speech model, okay, you can always save it, get back, and use this part, create CDS from the token file. Okay, so before that, before creating the CDS, you have to create the token file. You need to talk these tokens to this tool, that out of these tokens I am trying to create the CDS, and I have maintained the tokens as I have just said in the previous step. So whenever I am pressing this button to create the token file, it will ideally generate an Python exe file for you. You need to run this file and speak the token names. And whenever this token file is prepared, you have the flexibility to adjust your token file. Okay, that we'll see very soon. And finally, when we are satisfied with the version of the token file that we should be going with, then we finally go to this create CDS from the token file. So I'll first go to the downloads, and I will remove these two. These are the remnants of the earlier test. Okay, so we'll be deleting this and running it afresh. Okay, so from here we'll be pressing it. It is generating or downloading a exe file for me. So I am trying to run this file. Run anyway. L1, L2, L3, L4, L5, L6, L7, L8. So now it should have generated a token file for me in the download section. Okay, I have spoken the L1 to L8, the tokens I have maintained, and now I am doing it. So what it is doing is, it is not capturing it properly, right? So what we should be doing is, we can always remove this L3, L4, L5, L6, L7 up to L8 is fine. L1 and L2 is missing. So okay, we are saving it and what either we can rerun this, or we can always reuse these two. Okay, so let's L1 L2. Okay, so now it should have, look, this L1 L2 L3 L4 L5 L6 L7 it has. So I'm fine with this part, right? So I'm saving it. Okay, so let's see. It is now L1 L2 L3 L4 L5 L6 L7 L8. Okay, so I'm fine with this version of source code, I mean the tokenizer file. Okay, so now finally what I will do is I will use this tokenized file to create the CDS view. Okay, so what I will do is I will go to the next section of Hanable, and here from the create CDS token from file I will use this option. So let's see. I will choose the source code from here. The name is SPCH6, if you remember. Package is Z Hanable, and transport request is this. Okay, so I'll be running with this. I have just created the CDS, this SPCH6 successfully, if you can see. So how to check? If I go here and if I do this, I have this one just created for me. Okay, you can always reuse the actual editor to Eclipse editor to align this. Okay, and if you directly run this as an ABAP application, you will see it is perfectly fine. It is running MATNAR, it is this and that, and if you maintain associations as well, okay, you can do that. So in one of my earlier examples, I had created something with associations. I mean, from here, the sample 1 or sample 2, if you see this sample 2, this is an association based. Okay, and if you can run this, okay, so this is a sales order that you created, and if you follow associations, it will take you to item or schedule lines. Okay, so this is a full scale example of how to create CDS views via speech. Okay, and as I said, the first step is to maintain tokens, and you need to define your speech model out there, and you can flexibly design your tokens. Okay, that I want to put this part there, I want to keep the CDS name as a separate token, I want to keep the association part fully in a separate token, joining partners. So it's all up to you. How do you design your token? And so guys, we have just demonstrated how to create a CDS view via speech via a tool called Hanable Speech. So we have just created that, and we have checked that we can also fully leverage the aspects of associations, field list, annotations and all. And as we have also planning to generate the token files, we have the facility to generate the token files via speech, but we will be adding the feature of creating tokens, okay, also via speech. So that part will be coming soon and will be added as an extra feature, so that you are fully voice driven, speech driven. Okay, you create your tokens via speech, you create your token file via speech, and you also run it via speech. And soon we'll be having this thing connected with a SAP CAI chatbot. Okay, so that it becomes a full-fledged thing. So the motto of the tool at the very onset, as I said, just to have a provision in case of any untoward incident to any of our Abapers community, to anyone who belongs to our community, in case of any untoward incident of loss of eyesight or loss of ability to type. Okay, so this tool can be handy. And so hopefully this will make sense to you, and section of the video is not a wastage of your time. So thank you for watching this video, and please share and subscribe Codon, and please support us by giving your valuable comments. Okay, and as I said in the very beginning, that I'm pretty sure that there are brighter minds galore outside this room to nurture this idea further and give us a actual relief in case of any untoward incidents. And this will be a great help to the community, I guess. And very soon we have different plans, as I said, that we will be integrating this. It is already configurable in Fiori, and we are trying to integrate it with SAP conversational AI. Okay, and other features like creating tokens via speech, and we'll be adding a feature to create mass CDS views via speech only. So we have just created one token file, so you can generate a single token file for multiple CDS views as well. So we'll be adding this feature to this tool very soon. So hopefully you will like this video and you will support Codon as you have been doing all along. Thank you for watching. Enjoy your day, and please share and subscribe Codon, the coding particle. Thank you.